Hello, my name is Robin Mitchell and welcome to this podcast for Electropages. In today's podcast, we are going to be joined by a Frank Cirolia from Advanced Energy. So without further ado, could you introduce yourself and your role?
Hello, everybody. Yeah, so my name is Frank Cirolia with Advanced Energy. I'm a field application engineer, basically deal with power, anything to do with power, from medical equipment, industrial equipment, robots, whatever needs power. But for the last 5 years, I've been sort of concentrating on horticulture, and I think some of the talk today is going to be on horticulture. But I've been with this company for 17 years, but I've been doing power for over 40 years. So it's more of a hobby than a job. So I enjoy getting up and playing with the equipment today and every day.
Can I just quickly ask you, did you say 40 years?
With this 40 years in the industry, 40.
Blimey. So you've got a lot of years under your belt when it comes to power. You know your stuff.
Yeah, I mean, I've been shocked a lot, believe me, playing with power.
I can imagine. So just before we jump into the details of this, just out of curiosity, what's the highest powers you've dealt with?
The highest power, I've worked on one just recently for horticulture that was 1.3 million watts of power.
That's a lot of power.
That's a lot of power.
And what kind of voltages? What kind of voltages are we talking about?
And then for voltages, for that one, the voltage was 250 volts. But I've done anything,
right?
1.1 volt and minus, less than 1 volt to thousands of volts. So being in the industry,
that's pretty impressive.
Play with a lot of this stuff.
Great. So jumping into this interview, it seems that we're going to be going down as you say, the sort of agricultural route of vertical farming. So could you just give us a quick overview of the challenges that engineers face when it comes to vertical farming and the power solutions that they currently have available?
Yeah, so currently everything started going from the outside to the indoors, right, for better controls. And then once you got it indoor, now you can go vertical, right? Because you don't have to have a large area of a single layer. So now you can go vertical, and now you can. It'll be dark, right? You don't need the sun anymore. So now you can produce more product. You don't have to wait the cycles. So now you make your own cycle. So now you make your own sun, right? And that's using lights. So what I've been concentrating on is basically the lights that are needed, because they use up a lot of power, a lot of energy for the lights. What the sun gives you for free, now you have to pay for with LEDs, or lights in general. And how it started was HPS lights, which were pretty, high pressure sodium. They were hot and hard to control, but that's what they used. LEDs were very expensive, and so some of the things that happened was these rooms would get very hot, because you have all these LEDs within these grow rooms. And so they needed a lot more AC. So now they're paying a lot for the energy to run the lights, and then a lot of money to pay for the AC that's needed just to cool them off in the grow area, right? And then when things failed, somebody had to climb up a ladder, and you're throwing away a light and the power and everything. So what's happening now is things have moved from the HPS lights, these high pressure sodium lights, to LEDs, because LEDs have been, the cost has gone down, reliability is higher. And you can sort of adjust them for whatever product you're growing. So you can control the spectrum of the light is a lot better than HPS lights, which give you everything.
And so you've got the efficiency by being very selective on your frequencies.
Right, so for the spectrum of the light now, instead of giving everything, and the plant only needs the bluish and the reddish, depending on its veggie or flower, you get rid of some of the greenish and yellow in the middle that was just producing heat. So now these lights are going to be good for your plants because they're specific for that spectrum of what you need. So a lot of good things happen with LEDs. The problem is LEDs still need power, right? And what's happening today traditionally is every LED light has a driver or a power supply sitting on top of it. So you would drive an AC source into this power supply or driver. Then this would convert it into some DC to power your lights. And then if you need dimming, you have two other wires that you need to come into the power supply or driver so you can dim the lights, because that's the other way of getting the energy savings is dimming. So you're not popping lights on and off right away. If you have a ramp on and a ramp off, you save a lot of energy in that little area. So for dimming, you need extra wires. So basically, the LED lights nowadays, or traditional, is you have a light on top of it, you have a driver, you have a cable that comes in for the AC, you have a cable that comes out to drive the light, and then you have another cable for dimming. And that's what's traditionally done now. That power supply on top of the light, not only is the light getting hot, but now the power supply on top of it gets hot, so you still need all that extra AC because the plants don't want to be close to that heat. And sometimes you lose that sea of green because you'll see the plants at a certain height, and then when it gets close to where the driver is or the power supply is, it starts to reduce in height to try to keep away from that heat. So you lose some of that sea of green, you lose some of that yield. But that's what's traditionally done now. And for us, our company, we sold drivers. We sold those power supplies to go on top of the lights. The biggest complaint we kept hearing is the grow area is just too hot. What can we do to get the heat out of the grow area? And that's where, the experience with power came into play. And we said, you know what, we think we have a solution for that. And so we thought, why don't we just take out all those drivers and put them outside the grow area into some centralized location? And instead of having a lot of little drivers, let's have a large bulk driver, and one that's easy to replace in case something fails, so that you can have a fast meantime before to repairs, right? You want to get those lights up or off right away, so if something fails, as soon as you can get that failure out of there, the better it is. And so we thought, okay, let's get all those drivers out of there. There's nobody going to have to climb a ladder to throw out a light and a driver, right? And so now you need less AC for the grow area. The plants are going to like that quite a bit. Now, since you pushed out all that drivers and power outside in some centralized location, we can drive the lights from that location. And since we just drive the lights, we can control them. And so instead of having wires for all the lights, everything's done at one central location for power and also to control. And since we're going to control, we're doing it using digital controls, we can actually get feedback, because now we know what voltage is on the lights and what current's on the lights. And if it's not within the limits that we can set, or the customer can set, if it's not within those limits, there's a text going out, there's an email going out saying, hey, you have a problem. There's a light that's not as bright as you think, or it's off, or something happened. So even before somebody can spot a light being out, we can tell them you have a problem. We'll also monitor the driver itself, or the power supply or driver. So if the fans are starting not to work properly, if it's clogged, if something's happening on the input, we can tell all that also, because it's a smart driver. And these are also hot plug drivers. So if something fails, you actually pull out the driver and throw another one in, and within 15 minutes you can be up and running. Where before, again, you have to climb a ladder, throw out a light, a driver, climb one back in, put another, and that took a lot of time and effort.
And so one question I've got about this setup, as you said, you used to have the light, the driver, the power conditioning all as one unit, right where the plants were growing. But now you're taking the power and the driver remotely away from those lights. But that still means you have to have a cable from the light to the driver and the power conditioning, wherever that's located. So my question would be, does the additional length of wire from the LED to the driver, does that induce losses that you would not normally have?
It would if you didn't do anything to the light. And when we first started, the customer, so when you look at when we first started it, you have AC going to the driver. The driver was typically, the output was actually typically a 24 volt light or a 48 volt light. So it was low voltage DC light. And when our first go around with this, we kept the light at 48, and what we found was you need really thick wires to go a long length when you use
Yeah.
48. So they would put a bunch in parallel. And, so we've seen that issue, right? That was the first time we did it, and we said, no, you can't stay with 48 because you can't go far with 48 volts. So what they did is they put 5 of those lights in series. So now 5 times 48, you're close to 250 volts as a series connection. So now the wire size, instead of being, a 2 gauge or a bunch of parallel, it's a good 14 gauge, very, cost. And now you can go up, 200 feet, 300 feet. The problem is when you put the lights in series, if one fails, the whole series fails, right?
Fail.
And so the next go around, the light vendor said, you know what, we're just going to make 250 volt lights, DC input. And that's what he did. So doing it that way, the 250 volt lights, now your wire size is fairly small, around 14 gauge plus or minus. And you can get to 250 to 300 feet using that technique. And so right now we've got probably 6 or 7 light manufacturers that make 250 volt DC lights.
And that kind of makes that makes a lot more sense than trying to keep up with the older 24, 48 volts, because I suppose that the biggest concern is the energy loss as well. So next to the heating effect from the driver and the power, if you've got too much losses in your cables, it costs too much to run. And I think it would be fair to say that, especially for smaller like indoor farm, I'm not sure what you call them really, because they're not farms. What would you call somebody who, I suppose an indoor farmer really, isn't it? Somebody who's an indoor farmer who has a small warehouse and is a very small business might find that those energy efficiencies are very, very important to keep costs down. So by having the higher voltage LEDs, they can basically lose less power in the cables. They can use smaller cables, which is also cheaper to install. And then your driver's remote is chucking the heat outside, not inside. And so that kind of makes a lot of sense what you guys have done. Now, there is also something that you are working on, I think, is the optimized power supply technologies, such as the advanced energies. Now, is it Artisan?
Artisan is a brand name because Advanced Energy owns, they're the mother company, right? And they have a bunch of brand names. Yep. And so Artisan is one of the companies that they had previously purchased. And our products is the ones that are used in horticulture, so that it's under the brand name of Artisan. But the larger companies, Advanced Energy, and they support us real well. So, but with the long runs, it isn't just about efficiency of the wire, but it's cost. There's a lot of savings in cost. The other thing if you are talking about efficiency and energy, is that normal drivers, because power factor, I'm not sure if you know what power factor is, but that's the quality of AC. And if you had a power factor of 1, the utilities will charge you the minimum amount because the junk going back into them is a lot less. If you want to. So power factor 1, there's nothing going back to them. As you go down to 0.9, 0.5, at 0.5, they're going to almost double your bill, because you're back a lot of junk.
And are we saying that the DC cables themselves don't have a power factor issue?
No, they don't. DC. But right, the DC cable, you'll have your IR losses, but they're not a lot. It's the power factor, because drivers typically power factor is about 0.94 to 0.96. The bulk, the Artisan power factor is 0.99. So you're going to pick up anywhere from 6 to 9% reduction in energy cost every day. Every day, because
and that's just from the energy supplier's point of view.
Yes, because the power factor. So every day you'll pick up that, and then, like you said, the little ones are the cable. If you can have, that's sort of minor compared to the power factor. That's the biggest savings, is the power factor.
And could you just give us a bit of information on the Advanced Energies Grow Insight flexible controller and monitoring system?
Yeah, so I had been talking about the feedback that you get when you use digital approach, right? So now you can have with Grow Insight. Not only will you get the feedback and you can set your limits, but you can do all your scheduling online. So from anywhere you are, you can set up schedules for your grow site. So you can have schedules for your different flower rooms, veggie rooms, or however you like it. It'll be off-site, in the cloud, and then you can monitor from the cloud as well. And so with Grow Insight, you'll be able to monitor all the lights and all the drivers, but you could also attach your sensors to it. So you can have your temperature, humidity, CO2. So you can hook up all your sensors to the same Grow Insight. And now all that information will go to the cloud, which is great because now if you have a bad yield, you like to know what happened. Was it too much CO2? Was the temperature? So you can go back and look at the data, right? If you had a good yield, then you want to go back and want to know what you did right? So you have all that data. You can have all these sensors to it. It uses either Ethernet, so basically you come from the cloud, it goes to a gateway in the facility, and then from the gateway it goes to these nodes at different locations. The nodes are where the schedules are set up. This way, if you lose your internet, the nodes still know what to do, and your schedules will continue until you get back online. But it can use Ethernet or LoRa if you want to do wireless, if you don't want to drive Ethernet all over the place. So it uses LoRa, and we use LoRa because then we don't care if there's a wall there, a metal wall, concrete wall. LoRa
it's going to get through. Yeah.
So it's slow.
Yeah, I've heard you can go very, very far, tens of kilometers easily with LoRa. So, and I suppose that's quite useful for remote applications as well. So if you're growing something very, very far away in the middle of nowhere, you've got the ability to bring that data back and then operate it from a place that might be more convenient. So you've got a data center here or some kind of control center, stuff's growing out in the field, and you've got sensors connected to it. Your system can still work with those sensors. So what you're suggesting is that it's not just controlling LEDs and power, it's also getting the insight from sensory data and used in the agricultural industry.
Yeah, so Grow Insight is the whole combination of trying to do it all, saving that data, and then, good or bad, you like to look at that data and see what it said. And like I said, you can set limits so that if things are going around and it's not correct to your limits, you'll get a text or email or whatever you like to set up, or both, letting you know something's not right. So there's a lot of nice things with the Grow Insight. In that, again, it'll help you grow because as you do things well, you try to go back and find out what did I do well and what can I do better. And I could see the future, AI is taking off, and everybody sees that now, right? But I can see that where you start giving that data to some AI program, and then it automatically starts to, depending on the temperature and CO2, it automatically starts to set up things for you automatically, versus somebody looking at it and paying attention to all that data. Hopefully AI in the future will help with horticulture also.
Fantastic. So to wrap up this podcast, I've just got one question for you, and that is, if the engineers who are currently watching this and they want to get involved with advanced energy and the products that you guys sell, what advice would you give to them?
Well, try to get to us early so that we can help, because we don't help with just the lighting. We help the electrician. In general, the best way to work with the lights, work with power, save you on utilities. So if you can work with us early on, hopefully we can save you money at the end, because using this approach, there's a large install savings. The one I talked to you about, a $1.4 million watt one, I had the electrician do 2 quotes for me. One with the centralized approach, which we took, and I asked him to give me another quote using the standard traditional way. It cost $110,000 to do the centralized approach, where the power's outside. It would have cost $218,000 to do it the traditional way. And this is just the install. It's not the drivers. It's not the lights. It's just all the wiring, the circuit breakers. So the install cost, you're going to save anywhere over 20%. This one was almost 50% savings. But some of those smaller ones, they were like 22%. So install costs, for sure you're going to save, quite a bit. So like I said, if you get to us early, we can help you even more especially on the install cost. Op cost, I already said, the power factor is much higher, and so you're going to save every day on your bills for that. And AC wise, you're not going to have all that AC for your grow area. So again, just get to us early, and I think we can save you some money. And
that sounds absolutely fantastic.
We have to
Brilliant.
move more technology into the growers that are kind of the old type growers, right? They're not used to the technology, but technology is going to help them.
I think that goes without saying. I mean, if you look at any modern farming sort of setup, they really are moving towards AI, sensory stuff, trying to figure out the best environmental conditions that needed to produce the best crop. Yeah. So that is definitely some exciting stuff. And thank you ever so much for taking the time to join us on this podcast today. Thank you very much.
Thank you for your time. It was fun. It's always fun. It's a hobby.
It always is. It is absolutely brilliant stuff that we do, isn't it?
Yeah. Well, thank you again.